All right, now statisticians generally use the median rather than the mean when reporting income. Now, this is because when one or more data items are much greater than the other items, these extreme values can greatly influence the mean. So if you have everybody's making about 20, 40,000, and all of a sudden somebody's making, 500,000, that's going to skew the data more to the right, and so it's going to really mess up your mean. So in cases like this, the median is often more representative of the data. This is why the median, rather than mean, is used to summarize the income by sex and race shown down here in this figure. Now, because no one can earn less than $0, the distribution of income must come to an end at $0 for each of these eight groups. Now, by contrast, there is no upper limit on income on the high side. In the US, the wealthiest 20% of the population earn about 50% of the total income. Now, the relatively few people with very high annual incomes tend to pull the mean income to a value considerably greater than the median income. Now, reporting mean incomes in figure 1211 would inflate the numbers shown below here, making them not representative of the million workers in each of the eight groups. So again, what we're doing is we're looking at the medians because that's going to be the best way to look at it. Because if we did it the other way, we would be skewing numbers way high, and these values would be wrong. And so here we got males, we got the white non-Hispanic, we've got the black, we've got the Hispanic, and then we've got Asian. And that was for males, and these are the median incomes. And here we have females, and again, the white, the black, the Hispanic, and Asian, and how they make their money, how much they make on average, or median. Well, it's the measure of central tendency. So that some people call this the average, even though it's the median value. And so that's again where using the right terminology is going to really help us get the right values in place here. All right, so with this checkpoint, we're supposed to look at the table there and estimate the peak net worth in millions of dollars for 10 US presidents from Nixon through Biden. And so it says for A, find the mean net worth in millions of dollars for the past 10 presidents here, or these 10 presidents. Find the median, and then describe why one of the measures of central tendency is greater than the other. All right, so for A, what we're going to do is for the mean, x bar, we're going to sum all the x's and divide by, well, in this case, 10. Okay, so what we need to do is we need to add all those together. So if we go to our calculator, we can add those together. And what we have is 17 plus 8 plus 8 plus 14 plus 27 plus, and then we have 77 plus, then we had 40 plus, then we had 135 plus, then we had the real big outlier, 3,200 plus, and then we have 9. So it looks like 35 is going to be our numerator in this case. So with that said, if we go and we write that down, we'll have 35 divided by 10, move the decimal place. So this looks to be $353.5 million for the average. Now, what about the median? Because now they want us to put it as a median. Well, now we have to put it in increasing order. So that would be an 8, then an 8, then a 9, then a 14, then a 17, then a 27, then a 40, a 77, the 135, and then our outlier there at 3,200. And we have 10, so remember that's 10 plus 1 divided by 2, so that's 5.5. So we need to look at position 5 and position 6. So 1, 2, 3, 4, 5, and 6. So we want those two. So the average is going to be what? Well, we're going to take 17 plus 27, divide that by 2. And so that would give us, going back over to our calculator, 17 plus 27 divided by 2 is going to give us 22 as the median. So this is going to be 22, and that's going to be $1 million. Okay, so this one's 22 million, this one's 353.5 million. Now it says describe why one of the measures of central tendency is greater than the other. Well, and that means why is the mean so much greater than the median. Well, and again, it all stems to being this here number throws them off. If this hadn't been so high, it wouldn't have made these numbers high. So what happens is it skewed it up to a much higher value. And so that is why it's greater than the other one. Okay, I'm not going to write all that down, but that's the reason why. All right, so let's pause there and we'll come back for some more.